Hi, my name is Muhammad Ali bin Hamdan, and now I would like to talk about the principles of pre-stressing. Let's go. So first we will talk about the concept and principle of pre-stress. Pre-stressed concrete is a type of reinforced concrete that purposely introduces internal strains prior to adding external loads. These stresses counteract the tensile stresses that develop during service, enhancing the concrete's performance and a long lifespan. Then the basic idea is to use high-strength steel tendons or strands to deliver compressive force to the concrete by counteracting the tensile strength brought on by the loads. This compression increases strength and avoid cracks. Now, I would like to talk about the advantages and disadvantages of pre-stressed concrete. The advantages is the sections remain uncracked under service loads. Then, the high span to depth ratios. Last but not least, they're suitable for precast construction due to advantages of applying precast. Then the advantages of pre-stressed concrete is the method needs skilled technology, hence it is not as common as reinforced concrete. It does require a high strength materials, which is costly for the project. Then there is an additional cost in auxiliary equipment. Last but not least, there will be a long needed quality control and inspection throughout the process. Now, as you can see, we will provide videos about pre-stressed concrete, which is delivered by Practical Engineering on YouTube, and you can check it out for further understanding. Then, I would like to move on to methods of pre-stressing. The first one is pre-tensioning. It is a type of pre-stressed concrete where steel tendons are stretched and tensioned before the concrete is poured. Once the concrete hardens and bonds with the tendons, the tension is released from the anchors, transferring compressive force into the concrete, which helps it handle loads better. The tension is applied to the tendons before casting of the concrete. The pre-compression is transmitted from steel to concrete through bond over the transmission line near the ends. Then, the bond strength between the concrete and the tendons is important because it determines when the tendons can be safely released. Individual wires or strands are used rather than bundles for better bonding for this method. Then, pre-tension method, tendons usually run straight between anchors, but sometimes supports are used to create bend or curved tendon shapes needed for certain structural elements like deep beams or bridge girders. Lastly, common use of pre-tension concrete include beams, slab, balconies, piles, water tanks, and concrete pipes. Now I would like to talk about the procedure for this method. First of all is build a frame for the pre-tensioning process. It is constructed around the concrete mold to hold the steel reinforcement in tension while the concrete hardens. Then we will like to tension the steel with the thread rods or other steel reinforcement, which will be installed to the mold and frames, and then tension by apply force to the steel. Then the process of pour and cure of the concrete. The mold will be filled with fresh concrete, often use a vibrator for consolidation to remove air bubbles, which can disturb the integrity of the steel, reinforced concrete. And then it will be allowed to cure around the tension steel. Lastly, we will release the tension. The nuts are unscrewed and the frame is removed after the concrete has been cured and hardened. Because the concrete bond has bonded to the steel, the tension in the steel is transferred to the concrete, introducing the desired compressive stress into the beam. Now I would like to move on into the second method of pre-stressing, which is post-tensioning. Post-tension concrete is a type of pre-stressed concrete where the steel tendons are stretched after the concrete has been poured and hardened. Unlike the pre-tension concrete, the tendons are placed inside the protective sleeves or ducts within the concrete, not directly touching it. After the concrete cures, the tendons are pulled tight by anchoring it at each end, which compress the concrete permanently. The way tendons are anchored depends on the type of tendons. The duct can be shaped in curve or bends during casting, which helps the structure resist loads better once the tendons are tensioned. Then there will be two main types of post-tensioning. The first one is bonded post-tensioning, which the tendons are bonded to the concrete by filling the duct with grout after tensioning. The second one is unbonded post-tensioning, which the tendons are coated or greased to prevent bonding, allowing them to move slightly within the duct. Then we will go the same as pre-tensioning, which is the procedure. The first one will be installing the sleeve using a smooth plastic sleeve, which will be cast into the mold before the concrete is poured. This sleeve will create a channel that allows the steel rod to slide easily within the concrete members. Then the pour and cure concrete process. The concrete will be poured and allowed to cure and harden completely. The third one will be inserting the reinforcement, which is most likely the steel reinforcement, such as rods or tendons, into the plastic sleeve after the concrete has cured. Lastly, the tension of steel. Bolts on the roots are tightened to pre-stress the steel. This action pulls the steel against the cured concrete, introducing the necessary compression into the members. Then, as you can see, this is the simple way to display the stages of pre-stressing, of pre-tensioning and post-tensioning. Then we will talk about the application of pre-stressed concrete. The first one will be buildings, underground structures, towers, water storage, offshore structures, bridge system, and last but not least, nuclear reaction vessel. Then this will be pre-stressed concrete, which prefer than conventional in situ. For pre-stressed concrete, it can achieve 30 to 40% higher load capacity. The minimal cracking will be improved, and the durability and corrosion resistance. It is faster if precast because only installation needed on site. It is highly initial cost, but 20 to 30% lower life cycle cost due to reduced maintenance. Long lifespan, which is typically 50 to 75 years with minimal repair. Then we will talk about conventional in situ reinforcement concrete. It is limited by tensile cracking, suitable for shorter spans structure. It will prone to cracking, which indicates lower durability and higher maintenance. Slower because it requires formwork, curing, and on-site concreting process. Lower initial costs, but it will cost you highly for long-term maintenance costs. And last but not least, the lifespan will be much shorter, which is around 25 to 30 years. And frequent repairs is needed for conventional in situ reinforcement concrete. So, when we talk about the pre-stressed concrete, we also have to relate it with the SDGs. So the first one will be SDG 9, Industry Innovation and Infrastructures. The first point will be enhances structural efficiency and innovation. The second one will be support suitable sustainability industrialization. Then the second SDG will be SDG 11, which focus on sustainable cities and communities. The first one will be enhance public structures, safety and durability for the public users. The second one will be the reduction of environmental impact, which can cause harm to the mother nature and indirectly influence the human health and humanity, in short. Then this will be our reference for this slideshows. So you can refer to this list of reference for further understanding. And that's all for me, I guess. I hope my presentation will provide you benefit in understanding the pre-stressed concrete. And without further ado, I will take my leave, and I hope we can. I hope this presentation will provide the benefit. Thank you.